Good afternoon to one and all. I, on behalf of organizing team, welcome to all the participants in the current session. Our expert speaker for this session is Mr. Rakesh Tyagi. Sir is General Manager Customer Service in AVL India Private Limited. With a total experience of more than 33 years, Sir has worked for 23 years in AVL India Private Limited. Sir leads a team of 116 people to provide customer service and commissioning of AVL equipments and provide customer and internal training. It is our privilege to have you, sir, for an expert talk in this FDP. Thank you for accepting our invitation. Now over to Rakesh Tyagi, sir. Thank you so much, sir.
Yeah, good afternoon, NIT team and everyone who has joined this session. And for me, this is also a opportunity to talk and share some knowledge on electricians vehicles. So I'll be sharing my screen and then maybe I'll request to give me confirmation that my screen and my audio is doing well, and then I'll be starting this. So I have shared my screen, my presentation.
Yes, sir. Yes, sir.
Okay, thanks for this confirmation, and we will go through this, which is around 1.5 hours. I'll be touching very basics about the electrical vehicles, which you must have seen in other presentations also. And the more focus will be when it comes for the testing of the major components of the electrical vehicle. So what are these major components and how the testing is required and how the testing to be done? What kind of facilities are required for testing? Considering different participants, it may be from the college, it may be some professors or maybe different types. I have tried to select my slides to make it as simple as possible, but as informative as possible for you. So either you are from electrical branch or automobile or mechanical, or I will say even if you are not from engineering, I can assure you that this session will be very useful for you, and you will be getting the latest technology informations and latest techniques. And I'll try to make it as simple as possible from my sides. Let's see how it goes. So when we talk about the testing and the electrical vehicle, one thing which is very, very important, which we have to keep in mind is the safety. Somebody may ask, sir, safety is required in all the testings. Even in the conventional engines, when we are doing the testing, the safety is important. So why this point becomes more relevant to this? Yes, because when you are doing the, let's say, conventional testings, engines and the vehicles, so you are more worried about the fuel, you are more about the heats, you are more about the smoke and some kind of harmful gases. But still, the injury from these is still manageable, I'll say, unless it is a big accident. What is happening in the EVs, in the electrical vehicles, because we are using a high volt DC voltage. And the people who are from electrical side will understand this very easily, because the AC voltage is in a cycle form. So even if you touch it or by mistake or accidentally, it attracts and it pulls back. So there is a still chance you will get a shock, but still it's not so dangerous. But when you have the DC voltage is when you have a high DC voltage, and most of the vehicles are being developed nowadays, they are trying to go higher and higher. So accidentally or by mistake or somebody, if you touch a kind of a DC voltage, it is like a you get connected to this, and there is a higher chance it can be a major injury. So DC voltage, high voltage DC is very, very dangerous. So what I recommend here is generally the people who are going in this testing area, there are some basic trainings. You can go for the safety trainings on electrical vehicles. which is I think a 1 day, 2 days course, and then you know everything. You get certified also, and then you can start working. But our session here is not for the safety measure, but I wanted to point out this specifically because this is important before we proceed further. So very general things like, of course, when you are working this, you have to cut off the voltage main source. Then basically a lockout. That's if there is some switch which can be switched on or switched off manually, you have to put some kind of a lock arrangement so somebody else should not do it. Even if you have switched off everything, check the absence of voltage. So the multimeter is a device which is used mainly for checking the voltage and current. So you can check the voltage to be confirmed that before touching any components, it is done here. And the ground and short circuit check. This is the safety, because if something happens, then your MCB or your fuses will go. So this needs to be checked. And also check if maybe you have switched off from a main device, but if some neighboring live parts or something is there. So electrical safety, especially the high voltage DC, is must, and you all should know it. This is very, very important. Coming to the electric vehicles, because generally we say electric vehicles are very new technology, new generations happening. Just I will touch a little bit the history. Actually, electrical vehicles are also there in the history. So let's say around in 1880 or let's say 1885, there were some vehicles which were used as a passenger vehicles. So what was happening? They were having the four wheels, and they were something like they had even the weather protection. So fulfilling the needs of that time. Then also, if you see that time vehicles, even their speed, maybe mainly it was in US, but the speed was around, let's say 62 kilometer per hour. So it was a quite significant speed was available there. That time the development was happening for two things: electrical vehicles and the, let's say, conventional fuel. When I use conventional fuel, let's say, just to understand, the diesel, petrol, and or gasoline, all these things are coming. So that time what was happening, there was no electrical starter. So if anybody was having this let's say a petrol car, he has to rotate one handle, and then he has to start. That's more painful for the. So what happened then in around 1912, or let's say around 1910, electric starter was developed. So all conventional vehicles were having the starter. So you rotate a key and then vehicle was running. So what happened suddenly in 1912, the electrical vehicles were going away from the market, and then diesel, petrol, and all these developments for around, let's say, around 100 years, it was going on. So then different needs, different emission needs, and different things were going on. But then later, even somebody was talking about electrical vehicles, then it was for the range, like how long it can go with a single charge. Then, of course, the newer type of batteries, lithium-ion batteries, the technology changes, and then this was started to grow in the electrical side. And then we had, of course, the environment needs and the pollution levels, and so many things were contributing. Again, let's say currently, if you see from Indian point of view, my slide is showing you that quite kind of category. Generally, these kind of categories are coming for the EVs. If you see on the left side, this is like electrical, you can say power basically, which is used either on airports or in hospitals or some kind of resorts. It has a simple DC battery, it has a motor, and this vehicle is used. But from the certification or from the development point of view, this is called the off-road vehicle. This is not running on the road, this is a Zoom. On the right side, you see there are two-wheelers. The two-wheelers is coming in two categories. If it is on the, let's say, less than 250 watt, or if it is more than 250 watt. So two category for the vehicles are coming. Generally, you can say the bicycle is also coming in the lower categories. Then it comes to the three-wheelers, basically. If we are using auto or some kind of a rickshaw to this. And then we comes to the passenger car, which is we say light duty vehicle, and then coming for the heavy duty buses or trucks. So off-road vehicle, two-wheelers, three-wheelers, passenger car, and the commercial vehicle, buses or trucks. When we discuss the EV, always the electrification comes from the conventional to hybrid, and hybrid is using let's say for example conventional fuel and electricity both. So just to understand how we move from conventional to let's say fully electric vehicle is just to know this. This is a conventional model. In most of my discussion, I will take example of a car, so it will become easy to understand, and we focused, let's say, one kind of a vehicle. So in this case, how the vehicle works, that you have a tank, your fuel is coming in, and this fuel is a power for your IC engines, and this engine is giving a drive to your car. This is the conventional mechanism. Then comes the hybrid electric vehicle. So what is happening other than this having this fuel and engine, you are having a battery and you are having an electrical motor. So it is the vehicle is working on two kind of energies. One is that conventional, and this battery is giving power to e-motor. And on the selected range or selected areas, this vehicle is being used in both cases. Then comes, but in this case, we are not having a kind of a plug-in. We are not charging it externally. Then comes the plug-in hybrid electric vehicle. In this case, what is happening? Same method to, let's say you have a fuel, you have a battery, electrical motor, and we can recharge this battery also. So this is plug-in hybrid. So you use two energies, your vehicle is run. And of course, the electric battery, when we say electric vehicle, then we know that we have a battery, we have an electrical motor. So our drive is mainly from electrical, and we are using our external charging for charging our battery. One more thing which is very important to know, but in this lecture, we'll not focus very much on this, the fuel cell vehicles. So in generally, globally, if you say what is happening, the passenger cars or the light vehicles are coming as electrical vehicles. But when it comes to the commercial, maybe going directly from as an electrical vehicle may not be a real solution, because the working range and once you charge, how long it can work when it is a heavy truck or some, this can be difficult. So fuel cell vehicles are used. Fuel cell, just to know in a very brief, fuel cell is a technology which is a non-technology which was used in military, or let's say it was used in space technology. Fuel cell is a technology which is a fuel cell works on a hydrogen, use hydrogen as a fuel, and the outcome of this will be our electricity, which is used for running a vehicle, and the output is a water, basically H2O. So this is also pollution-free, let's say, systems. But this fuel cell has its own concern, because the hydrogen which is available in cylinder is at around 700 bar. Then, as I said, it was used very specific reasons, space and military. So this technology currently is not so cheap, but development is happening to make it cheap and to make it usable on the passenger vehicles or the commercial vehicles. So in general, trend is coming. Fuel cell will be used for the heavy duties, and the battery, electrical vehicles for the passenger cars, and two-wheelers will be on electrical vehicles. So our main focus here will be on the electrical vehicles. Now, as we said, we can be electrical, we can be mechanical, automobile, or other this thing. Just to know the electricity and the electrical vehicle, when we are going to use different testing methods and what is happening. Take one example here. Let's say you have a pressure, you have a pipe where you are having a liquid on some pressure. And then this is, we are having a, let's say, turbine, which has to rotate when we release the flow from let's say, water from here. So we have a pressure, then we release the flow, and then we get our work done. And so what is happening in electrical form? Three things we are simulating. Three important things which we should know, and we will be doing the measuring and testing. The voltage, how much is the voltage, how much is the current, and how much is the total power generated. So here the pressure in a tube is an example of voltage. So high pressure, like high voltage, you are having available. How much flow you are releasing will be known as a current basically, because if you are releasing more current, then you will have the higher power. So high flow, higher power. Similarly, you have a voltage here, you release the current and you get more power. What is happening in this case, let's say how to control this flow from here, or how to control the current here, then this comes the resistance, because based on our resistance, then we control this. So the voltage, current and power, these are the three things which are main measurable things when we are talking about the electrical vehicle or the testing of the. Okay, now I think most of you know, and this is our method here now. That there are three major components, because when you have an electrical vehicle, or you are planning to develop an electrical vehicle, or somebody who is working on in this technology, three important things are in a electrical vehicle. Battery, we all know this is a source of energy, and this is storing a DC current, DC voltage here. And when we use this, DC current is flowing. DC current is shown always with a plus and minus. So this is our power available with us. E-motor, electrical motor, this is the part which is used for giving the drive. So with the help of e-motor and with some transmission, different kind of transmissions, we are getting this motor is working to rotate the wheels, and finally we are getting the drives. And then this comes, the inverter comes in between. What is happening, what you see here in the market, let's say if you see a small scooty, a two-wheeler, generally what is happening, we are having a battery, we are having a DC motor, and then this battery gives power to DC motor rotates, and this, using some transmission or using some gear arrangements, this output is going for the wheels. But this is not the best method of making, utilizing a electrical vehicle. This is not done. It's maybe suitable for only for smaller vehicles, or for the two wheelers, but this technology cannot work in longer, because this is not efficient. So when it comes to find the efficiency, and when we have to increase the range of any vehicle, we have to use the AC motors, synchronous and asynchronous AC motors. Now, when you need a AC motor, you need a AC supply, that is three phase. The power available with you or with us is the battery, which is a DC voltage. So what inverter is doing here is, this is changing the DC supply to AC supply, and vice versa. We will see in coming up slides. This is also doing the reverse job, because when vehicle is running, and when we use a brake, I'm talking a optimized vehicle. When you are using a brake, or let's say you are going down the hill, so then this energy which is self-driven is consumed, not consumed by the motor, but this is feedback. So our inverter is working, is taking DC voltage and giving to the motor, but from the motor also it is taking, and it is charging the battery. Now, once again, I'll say, let's understand, because with the help of hybrid and let's say conventional and this. So this is showing one example of, you have a, let's say example of a car, you are having an e-motor, and this is showing an engine. So you are having an engine, you are having an e-motor, you are having a battery inverter. So this is the, let's say, transmission arrangements, and this is called parallel hybrid. In this case, conventional engine and e-motor both are working to run a car. This can be in a different way also, because the front wheel, let's say, it is run by the engine, and but this battery, inverter, and this motor is on the rear wheel. This is also one example for the parallel hybrid. When it comes to the serial hybrid, what is happening? What is the difference here? Finally, my drive is coming with the e-motor and inverter battery, and my engine is working as a generator. So my engine is just generating the power and this giving to the battery. So my vehicle will be always run on electrical power, but engine is working as a generator and charging my battery. This is called serial hybrid. And of course, then the best method which is used for this is the power split here. What happens? You have a battery, you have a inverter, and you have a e-motor, and this is the third combination possible. So your engine is also giving drive, but your this depends when do you want to generate the power, when do you want to save the power. So engine is feeding direct power to wheels, but sometimes this is giving power to the let's say to the battery, and then other method is it is used from the e-motor. So a parallel combination is working. Okay. Now let's move to the electrical vehicles, and maybe like this most important is and how the testing and how challenges are coming. So you see one example here of the this. So what is important here to know that the weight. This is a model of, let's say, electrical car, but if you see the base, the battery, the base is always very heavy. All the batteries are stored on the this area, base area, and if you see the overall weight of a electrical car, the main part come the batteries, and this itself is a challenge for available let's say passenger cars, and how to take it, how to reduce the weight of the battery, and how to make battery more efficient, and how to optimize, how to select a motor that it is giving you the best efficiency, how to optimize my inverter in such a way that this is not only taking power from battery giving to motor, but whenever it is required it's saving power. So kind of a two sides energy saving. This is happening. Okay. Now, when we talk about electrical vehicle, we know that we need a electrical motor which will be giving the drive to the, let's say, car. We need inverter because inverter is required to change the DC power into AC power for the motor, and in reverse way AC power to the battery. Third, yes, we know battery. When we talk about this battery will not be a single battery. This is a kind of a set of batteries, or we can say power extender, different models. But ultimate thing is that this is the power available. So power available going to the inverter, getting changed into AC, motor works. What else is needed? Because once your battery is discharged, you have to use the main supply. So a kind of onboard charger is given, and we connect this to the main supply, and then this is giving charging to the battery. And when we are charging the vehicle, when we are not using the vehicle, this is getting charged. One more important thing is because this battery voltage depends what kind of car we are talking about, what kinds of development we are doing. But let's say, for example, this can be around 200 volt, this can be 300 volt, 400 volt, or in some cases this may go even about 600 volts also. This is the high voltage DC, which I was also talking about the safety. But the accessories, because let's say you are having a music system in your car, you are having air conditioning in your car, you are having headlights or different combinations. So all the accessories which are available, let's say in the current situation, conventional car, they are working on 12 volts. So you cannot change everything to the high voltage. So what is happening? We are having a DC to DC converter. So purpose of this is whatever voltage, for example, 200 volt, it is taking from here and it is converting this into 12 volt. So accessories, all the accessories are working on 12 volt, and my inverter is getting, let's say, around 200 volt, 400 volt with this. Also, I think all you know that most of the vehicles are having two kind of a charging, quick charging and standard. A difference between quick charging and standard charging, and to understand once again in a very simple way, you can take example of your mobile charger. Because when you have a high power charging, yes, your charging will be very fast. But if you see, every battery has a life of how many charge and discharge it can bear in a one life. And if you use standard charging, for example, it has a 1000 times you can charge discharge. But when you are using quick charging, of course, it's so a general understanding is when you don't need a quick charging, please don't do it. Let's say you are at home and you are planning to go to the office having a electrical vehicle. So overnight you have a time, so you should go for the standard charging. But suppose you are traveling somewhere, you stop on the for an hour or so, and you want to go for the charging where you stop just for to having some tea, coffee or something, then you can go for the quick charging. So optimized way is when you have time, use our direct charging, but when you are not having time, use quick charging. But don't always use quick charging to save the time, because the life of battery will be reduced. Now, as we discussed this DC and AC things, so let's understand about the motors, the basic things. So we have two type of motor. Most of the development, most of the things are coming up now. Let's say electrical motor technology and testing and efficiency testing. These are so we have two types: asynchronous motor and the synchronous motor. So the asynchronous motors, kind of induction type of machine, they are not having a permanent magnet. It is very mature technology, but one thing here is the efficiency is a little slightly lower when you compare to the synchronous machine. And in because we have a battery available, we are running a car. Efficiency is a very important thing. So synchronous machines are having permanent magnets, and because they are used for the high efficiency and high power density, and power factor near one, that means efficiency is almost 99 to 100%. And if you see the overall, because the permanent magnets and repairs and other things, so synchronous motors and asynchronous motor, but synchronous motors are let's say winning a little bit compared to asynchronous because of permanent magnet and high efficiency. One more thing to discuss here, just about the some kind of a benefits or some kind of a this, because when you start developing any motor or start developing any vehicle, you have to see the power and torque curve. So what is happening here? If you see the torque value here, even on the lower side on the speed, so you can get the highest torque possible, highest torque available in your electrical vehicles even at 0 RPM. So this is one of the benefits. So your starting and your initial ramp up, all these things are very useful. So the DC motors, when we say the DC motor, I think that is only for the two wheelers, or only you can say the technology, the development is not so much. When we say efficiency and increasing the range, all the development, all the testings are for the AC motor. So we are talking mainly for the AC motors. More important thing, when you have a battery, inverter, and motor, this is not one sided, this is the two sided. So what is happening when you are using this as a motor? So electrical energy converting to let's say when it is rotating, this works as a motor mode. But on the reverse side, the mechanical energy which is available, and we are using generator. I gave an example. Let's say when you are slowing down, or when you are going down the hill, so we are using the brakes. So system works in this way, or my inverter is optimized in this way, that all this energy is fed back to the battery. So in motor and generator mode, this is technology, and this has to be optimized, and the best efficiency is possible when you are going on this or developing your inverter. when it comes to the inverter, very short brief that what is happening. So we have a AC pulse. When we say AC machine, so the current will look like this. It is an example of three phase. When you say you have a DC, so DC is indicated with this way. So with the help of your maximum current and maximum your variable frequency, what is available. So different technologies are coming. But you to understand in the simple way is like your IMAX, your maximum current will be responsible for your how much torque you can achieve, and to change the AC because when you have to achieve the different speed, when you are running a vehicle, you have to run vehicle on different speed. So your frequency of your AC voltage is directly related to the speed. So this AC technology and conversion from AC to DC, that is DC to AC and AC to DC, this is mainly the inverter technology is. How it happens in a very simple way because there are different switches are there. We can say very most popular is the IGBT and also the FAT transistors, basically MOSFET or FAT transistors. So what is happening ultimately? What is happening with the pulse width, with the controlling the pulse width and the switching speeds, DC to AC or AC to DC technology is working with the inverter. So main task is when AC is available and when we are working in generator mode, it goes back to battery, and when battery is available, we are working in motor. This works to AC to DC to AC. If you understand what we have discussed now can be understood from this. Let's say battery or fuel cell. So you have a power available. Yes. This is DC power. So this is 2. It's a plus and minus. So this is going to an inverter. And what is required here from the measurement point of view, we will be having a two channels measurement here. One is the voltage and the current. So how much voltage is available and how much current is flowing here, this is measured here. Then comes the inverter. Inverter will convert my DC to AC, so then it will become three-phase supply, which is going to the motor. So AC supply, then we have basically the three channels available here. Three channels we use for the voltage, and we use three channels for the currents because we want to measure when it is working as a generator mode, when it is working as a motor mode. So we'll be measuring this. This is the second measurement. Now, from testing point of view, because if we install a battery, inverter, and e-motor in a car, we cannot install. So what is happening? We have to simulate this in a test cell. So when I'm running this setup, so e-motor has to be loaded. So you know the dynamometer is a device which is used mainly for loading the motor. So different road conditions can be simulated, and this technology can be tested in a test cells. And so this load unit is used for loading the e-motor in different combinations. And we have here basically the speed and the power basically. And with the help of torque, because how much torque we are putting, how much losses are coming here. So with the help of my torque and speed, I know how much power I am putting. So this dynamometer is used to load the motor, and I can this is active dyno, so I can also run the motor if I want to simulate the downhill condition. Then also I can run the motor from this dynamometer, and then this can go power feedback. So this technology is used in most of the testing areas. So now we go to the let's say real testing environment. So what is required for testing? What I need? Uh, let's say input supply, three-phase input supply is available, AC supply is available there. So I need conversion from AC to DC power, then DC to DC converter. Why DC to DC converter is required basically? Because the technology which we are having, as I gave the example, there may be a development required when I'm using a motor of let's say 200 volt DC. The other maybe I'm using a motor for 400 volt DC AC, or maybe a 600 volt. So my facility should be in such a way that generally what is happening, I'm having a 800 volt AC available here, and then I get 800 volt DC here. Sorry, 400 volt AC which is available, and I convert 800 volt DC here. And then based on my need, I can use DC to DC converter. If I need 200 volt, I need 300, 400 volt, I can uh, convert the DC to DC converter. How this is being done is, AC to DC, we have a rectifier, then we need an intermediate circuit, and this is called step down converter. So step down converter is changing a high voltage to the lower voltage. This is done. This is done from the testing point of view. This is available in a cabinet. A complete cabinet is having where you connect the AC power and your rectifier, your DC to DC converter as per your choice. Your DC to AC converter is done by the this cabinet, and this is called a e-storage device. So what are the this e-storage device? What are the purpose? E-storage device, let's be used as a battery tester. So this device can be used for testing the battery. This device can be also used for battery emulator. Battery emulator. What is emulator? Let's say if I am testing a battery, I need a battery tester. But when I'm, let's say I'm checking a motor, I'm doing a testing for the motor. So I cannot always use a battery because when I do start doing my testing, after sometimes my battery voltage is go, and I cannot do a long testing. So this e-storage device is designed in this way that it works as a battery emulator, or you can say battery kind of a simulator. And how it works, because this will give you the power whatever you need. Different kind of batteries can be simulated. You select a model or a type of a battery, and this e-storage will work in such a way that it will emulate as a battery. So you can do the emulator testing. And then it as a better and battery emulator. So if you are testing a battery, you can use this as a battery tester, but in some cases there are some tests where it has to work as an emulator. So battery tester and battery emulator for both things, this is working, and this is the storage. That's because this is one of the most important device. So we know a little bit more about this. What are the features available? So it will be having a, let's say, on off switch. There will be some rectifier circuit. Then generally there is a touch screen here where you can do the different kind of a programming what you want. You want as a battery tester, what is the voltage output should be there. So this is a, let's say, operator panel. And then if you see inside of this, there will be some kind of transformers like filters in the inlet line. Then there will be some kind of let's say main switch and some filters available. And there will be a controller card, which is the main IGBT panel. And so this you are getting a AC, and then with the help of IGBT, you are getting the DC. There are some fuses and there are some cooling arrangements. So the main purpose of this cabinet is taking the AC, changing into DC, required DC, and the control circuit. And it also had some kind of a network connection. So this can be interfaced with the automation system or your PC, how to do it. Then comes to the, this is just one example of, let's say, 160 to 200 kilowatt. So what is happening, because when you are changing the DC, then once again, it has to go back to the e-motors, and conversion has to in such a way that your e-motor, your inverter, all these are getting power from this, and the AC to DC, and your required voltage of DC is fed there. And this is the second side cabinet where you are having, let's say, you have to storage DC. So having this DC voltage stored in a way, some capacitors and some kind of optional things are used to perform this. Then power distribution units, because when you are connecting a motor, you cannot connect to the mains panel because it will have a high voltage and it is not safe. So a small panel, this is called power distribution. So our cables are coming from main, let's say main cabinet to a smaller box, where this box is having a voltage meter. It knows how what is the voltage. Then you have some operational on-off switch, some reset switch, and this panel is mainly used. So when you change your motor, your battery, or anything, this device is used. What is in this device? Because our main measurement is happening here. So it has a small PLC for the safety. So if the door is open, like you cannot switch on the panel, and there is no harm for the, let's say, user or a developer engineer. It has some fuse, it has some discharge resistor. Discharge resistor means, when I switch on the panel and I'm using, let's say, for the DC supply, when I switch off, let's say I'm working from 9 to 6 o'clock, 6 o'clock in the evening, I switch off the panel. But this charge, DC voltage is still that takes around 15 to 20 minutes. So in 15 to 20 minutes, whatever charge was there, this will get discharged. Then it is having a grounding circuits for that is for the safety. And then you can see here a kind of a current transformer. This is one example. Like when you are doing the testing, how much current is flowing from this? This is measured by this current transformer, and this is going for the automation system. Then you have on the lower side, you can use some cable glands here. So cable can come in and go from here. And then it has some filter capacitance and some other kind of safety norms here. So this is the box where you are connecting your battery or e-motor or inverters. So what happens, this is one example. Let's say you are having a three-phase e-motor testing here. You have a three transformers. So what is happening when we are using this, all these transformers and voltage, the voltage and current values are coming into analyzer. And this analyzer is collecting all the data, and then this analyzer is talking to the automation system where we see how much values we are going there. Voltage and current, this is just one example because how the voltage measurement is done. So this is one device which can be used, which can measure around, it can give you the, let's say, plus minus 1000 volt. Then the current transformer, you know that because generally these are installed in the series, and these know. And you can select what kind of a resolution you want, how fast data you want. You can choose, but this is one example. Generally, the message is that we are using high resolution these devices for the voltage and current measurements. This is one example of when you use voltage or current, finally the voltage is going here, input, and this is doing a kind of a processing, and then this is going to the automation system. Now, let's understand how when it is a test cell and how the automation system happens. So once again, we have a motor, we have an inverter, we have a battery. Yes. The battery testing, for the battery testing, what we need a automation system. In AVL term, we call it links. So this is an automation system, and I'll be discussing some details in the coming up slides. But currently, you see, let's say one automation system is required, and then this is we have told that this is a e-storage, let's say storage system. So how this is possible? If you have a storage, you can check your e-motor. So you have a battery, inverter, and e-motor testing. What you need, you need a dynamometer and a kind of a automation system. So battery is available, inverter is available, but e-motor testing can be done from here. On the other way, let's say you are already having a e-motor, you are having a battery, but you are doing a development for the inverter. In this case also, you can have a e-motor emulator, or you can have a e-motor actual e-motor. So your inverter can be developed with this. So either battery testing, if it's a battery testing is here, or if you use this can be work as a battery accumulator system. So battery is not directly developed, but e-motor and our emulator is developed. So now we will go with the three important things. Let's say battery testing, e-motor testing, and inverters testing. For the battery development, if you talk about the major challenges, what is happening, because everybody wants the lightweight and the high efficiency, and uh, uh, your your program and your methods with the battery, how newer and newer technology you can use it. So you have to go for this. Then everybody wants to increase the life and using the aging effect. Yes. And you have to check the performance when you are charging or you are discharging. What is the optimum way of charge and discharge to get the higher life? And how the transient response means when you are going when you increase your speed suddenly in a car, or when you reduce the speed suddenly in a car, what is happening? And also how it is working against environment. So the temperature conditions, if you are using a battery, let's say between 15 to 40 degrees centigrade, how it works. But if you go beyond 40, let's say you go 45, 50, or even 60, so what is the effect of high temperature or low temperature on your battery? And because if it is installed in a vehicle, you will be going during rainy season, you will be going through water on roads. So different testing combinations are possible. For understanding the battery, when we say battery, in general, this will be a kind of a battery pack in a car. But what is a simple cell which we use in our remote control is a cell. This is also kind of a, it's a cell battery. Then you have a different combinations of the battery, and then we use it battery measurement system. So then we can make a module. Then if we are using this module, now we want to make a temperature control. So we make a temperature heating and cooling arrangement in such a way that this battery should maintain a fixed temperature, because the performance of the battery will be well maintained in this temperature. And different combinations of the batteries is called a battery pack because how I am developing a car, as when I said 200 volt or 400 volt, or even let's say 600, 800 volt. So generally a one cell produce 1.2 to 1.5 volt. So higher voltage means it will be having more combination of these cells. So different battery combinations are possible. And this is giving you, let's say, some kind of a picture when you have an independent cell, when you have a battery module, and battery pack testing. So this is kind of a battery which is used in the electrical vehicle. I'm taking example of the cars. Battery are also end of line is testing. So when you are producing the battery, so before battery gets qualified for a dispatch or for the sales, then also different methods are coming. It's end of line testing we call. So as we discussed, we need a storage battery tester. Then we have a automation system. In avial term, we call it links. What is your automation system? Because you can do a kind of a pre-programming. You can feed your data of the battery, what kind of battery you are using, what is the maximum voltage, what is the maximum current. If you want to install some kind of a safety norms that my battery current should not go, for example, about 100 ampere or so. So you can define a monitoring here. If it goes above 100 ampere for any reason, you will get a warning, or your testing will get interrupted. So some kind of a safety can be done here. Generally, this links automation system is connected with our storage with the CAN communication. This is happening. So battery, because you know the battery, the safety concerns and battery, we have norms for testing the battery, especially I think for the all batteries, but automobile battery, because it is moving and it is always on road, so there are safety norms. So what is happening generally for a chamber is can be programmed that you can have the different temperatures here, temperature conditions here, And in case you have a problem with the battery, explode or any kind of a problem, then we have a exhaust arrangement. We have some kind of a sensors there. They can detect different gases, and they can give you an alarm that something wrong with the battery. So generally this test cell area, battery is kept in a environmental chamber. Then, of course, because the automation system, we have a storage battery tester, and this is test cell area. So this dotted line shows that the operator sitting here and doing the testing, but this will be in a different room. And generally, what happens when you are doing the testing, operator is not allowed to go inside. Even if your battery testing is over completion, and generally for next half an hour you are not allowed to enter in this area, or you are not allowed to open this environment, because depends on your testing. But some testings are like this. Battery, even if battery is showing everything okay, performance okay, but there should not be any leakage, there should not be any overheating or something for next 30 minutes. So this is a general test is done. So this is one example. When it comes just know more about this is, so let's say this is unit test. So this is, let's say, battery I'm testing here. This is e-storage giving a, let's say, DC power to this. I think this is clear now. And what are the other things possible? Let's say my automation trolley, signal from different things. This is a climatic chamber, so I can program different humidity conditions or cooling arrangements here. This is also connected to the automation system. Something happens, so my fire, not only the detection, but it will have some kind of a gas filling or some kind of a water mist, depends our system. But some safeties are also happening here. So in case of problems, the gas can go inside. So firefighting arrangements are also there. What are the other possibilities? You can install a camera. Generally, the camera is installed because while running and while doing the testing, you can have a close watch on the battery, that how it is looking. If physically any change on something is possible. Your temperature, pressure, and voltage measurement. We have discussed that whatever voltage current is measured, this is captured by our, let's say, system, and this is feed to the automation. And there are some reset bus simulations, because what is happening, the different kind of battery and different kind of automation systems are there. So this is also some kind of a simulation. Like during running itself, you can do some you can change some program, and some automation for UUT can be done. Coolant conditioning is a device which is common, because depends on your model. If your cooling is a air cooling, no problem. But if your cooling is a oil cooling, or your cooling is a coolant cooling, so some kind of a conditioning device is there. The purpose of conditioning is that you can temperature here, for example, centigrade. So a coolant will be flowing always through your UUT, and then this will control by heating or cooling here. Your temperature of UUT will be always this. This conditioning unit is same. Either you are using battery, if it is a coolant cooled or liquid cooled. Either you are using a e-motor or inverter. Conditioning unit purpose is to keep the temperature maintained. So as we say, power supply, because you also need 12 volt for the accessories. So 12 volt, the battery management system, this will be available. So in general, all these sensors are giving input to the automation, and automation is also controlling how my storage should work, and climatic chamber, fire, safeties, monitoring. This is the way the test cell will look like to the battery. To see the automation system, as I told you, generally almost all the flexibility is given. So user need not to think too much with this. Here he can program the basic things. So there is like monitoring what kind of a UUT you are using. The data, whatever is captured, is logged, and you can make a automatic cycle, like maybe initial warm up, different steps of cycle when you are doing the testing. Also, what is the voltage, what is the current, what is the power, and how my monitoring is happening, if there is any error message or anything. So you can also install pressure sensor, temperature sensors to monitor the environment or to monitor the different climatic conditions, and all the parameters coming on this automation. And then this is having a different combination, different safety norms, also different kind of a guidelines also here, and automatic testing of a battery can be done. This is just one example. Let's say you are let's say acceptance test for the charging cycle or discharging cycle. So you want to monitor this, let's say, cycle, and then you are running this automation. You have programmed this, and your data will be captured, and finally some report of something like this will be shown to you, so you know what is my purpose, what is happening. So charging cycle, discharging cycle, or many other combinations are possible for the battery testing. As we said, the e-storage, because this device is used not only for the battery, but this device is also used for the other automation systems also. So what is happening when it comes to the e-motor, and we are moving to the inverter now. So e-storage will remain same here. And as I told, the power distribution unit, this is also available. So you can use this for connecting your UUT. And the automation gets changed. When it comes to the e-motor and inverter, so our testing facility, our testing requirements are, I will say, much more requirements. Battery testing is easier compared to, very simple to compare to e-motor and inverter. So you need a more powerful automation system. You need more features in the automation system. So this is one example. Let's go to the e-motor. So when it comes to the e-motor, our challenge is because the speed and torque controlled at 0 RPM, because this is one of the USP of the electrical vehicle, that on even on 0 RPM you can get the highest torque. Dynamic behavior, transient behavior, because the motor, let's say motor heating, the motor is working very fine, everything is okay, but this cannot take the temperature if high ramp up and high ramp down is happening. So all these parameters and all these testing has to be done in advance. Of course, it should be very reliable and durable. So a kind of endurance test has to be done. How long, how many hours this motor can work non-stop, and also what will be the life of this. And of course, the environmental situation, like a temperature is most important, but what is the effect if you pass the vehicle through a rainy season, or when there is a flood or roads. So all these conditions are there. And one of the most important development nowadays is happening for the increasing the efficiency, because if the motor is efficient, then only your vehicle will get sold, or vehicle will get a kind of a USP over other product, because efficiency has to be there. Comes to the e-motor test bed. So let's say we have a motor. What you need, first thing is you need a dynamometer, a loading device, because we have a e-motor in a test cell. So this is a, let's say, dynamometer. It can rotate the motor, it can load the motor, it can absorb the power, and it can give the power. So dynamometer is required. What else is needed? We need a automation system. So we have a automation system, we have a e-storage device, and in this case now this e-storage device will work as a battery emulator. So this is like a battery. So when I'm testing a e-motor, this will work like a battery, and this program is done like this. If you are using a particular battery, like most of the models which are available as on today in the market are stored software wise here. So when you select a particular battery, this storage device will work as a, it will simulate, or it will emulate like this particular battery, how this battery discharge behavior, how this, what is the voltage of this battery, and how it works. This will be same. So in this case, you have a test cell, so you connect your e-motor here, and then this works as a e-motor test beds. And generally what is happening, if you compare with the conventional testing and this testing, our speed of the dynamometer will be very high, because in India, what I have seen is the maximum speed of this dynamometer running a engine I have seen around 7,000 RPM or maximum 8,000 RPM. So almost all engine types are covered up to 7,000, 8,000. But for the e-motor testing, you should have up to 20,000 RPM. So motor has to go high. Torque depends what kind of a motor you are using. Then this is a sense cable. So whatever current and voltage is measured here, it is going back to the e-storage and going back to the automation system. Also the control, because whatever voltage you want here, safety concern. Let's say if you open this and you are connecting the motor, the power will be off and the power cannot come. So safety concerns are here. And also, as we discussed, because we are measuring our power measurement here, and so voltage, current, and over. This is our measurement system, and this is going to the automation. So this is working as a battery emulator. I'm doing the e-motor testing here. I'm using device loading different combinations, and my automation is doing automatic test and all the data here. Now, what happens if you see, because in actual condition, if you see in actual condition, this area of will be changed by the battery. Ultimately, a battery will be giving the power to the e-motor, and the inverter will be this. And our dynamometer, which we are using our loading. So what is happening? The vehicle will be loading the e-motor. So this is the explanation. So what actually has to be done on the road? We are testing this in our environmental, in a test cell environment. We are checking this in a cell. So this is replacing our vehicle, and our left side, our automation is replacing our battery systems. This is the combination. This is giving you an example. Maybe some of you must have seen, let's say, engine test bed is happening. The generally, I told you, around 8,000 RPM, and there'll be a pallet. Engine is coming here, and this is getting installed here. So the engine part is very bigger. The weight will be very high here. In this case, this dynamometer control will be very smaller, but high speed. Here it is 8,000. More torque is required, because here it's not the high torque but the high speed. And generally here the automation happens, that engine is connected here. We are using a crankshaft, different combinations, sometimes transmissions also. But here this is motor is plugged directly to this. So this slide is just giving you idea if you compare the conventional testing and to the e-motor. Now, if you see the overall setup, it will like this. E-motor, you have a inverter here. Generally, what is happening when voltage is coming from the battery, the inverter and motor should be as close as possible. The main reason is there should not be any power loss during the chaos. Ideal situation can be your inverter is installed at the top of e-motor, and you have an interconnection in between. But this is the area which is during a development test beds. E-motor loaded by a dynamometer. Then what are the other things are having? This is we have talked e-storage coming DC here. Inverter is giving 3-phase here. Temperature, pressure, and voltage measurement, coolant conditioning unit, some kind of a mechanical system, but these are mainly how to install this, how to make it free. It should be vibration free, nothing should be loose, something like this. And then this is the automation system. So this single automation system is connected with most of the machines, and then some kind of a combinations and some options are also possible. So this is a combination power management. The yellow area shows that you are at testing facilities. Just when you will see inside a test cell, it will look like this. Automation system here. Dynamometer, motor is here. This chamber Because as I told you, the environmental conditions have to be checked for the e-motor. So let's say you want to check how my motor behaves between 5 degree to, let's say, 60 degree, for example. So this environmental chamber is automatic control. You can set your temperature here, environmental condition, temperature, humidity, even if you want some condition pressure. So mainly temperature. So how my motor works, 10 degree, 15 degree. So this environmental chamber is automatically changing as per your automation requirement, then the climatic condition for the motors. This is dyno cabinet, power cabinet. These are the trolleys where your e-power measurement is done. So we get voltage signals here and going to the automation system. Then this is power distribution unit, how to connect coolant conditioning. We have discussed that based on my requirement, this is happening. In case of motor and inverter, there are different combinations possible. Let's say there may be a conditioning unit for the e-motor, so controlling the temperature always at 50 degree. Second conditioning unit which is used the inverter, again having a temperature. But if inverter and motor is a combination, or let's say one OEM is having one testing area, so sometimes coolant condition, one single coolant conditioning works for inverter and motor together. So motor inverter combination work like they are connected in series and they are maintained at the same temperature. So this combination. When it comes to the base, you see this here, and there are 4 or 6 air values, because when you are running this at 20,000 rpm, there is a chance that heavy vibrations can be generated here. So these vibrations should not have any effect on the performance, or they should not disturb anything, or these vibrations should not pass to the other testing area. So generally the air cushions are used here. So whenever testing starts, this base plate will be on air cushions and no vibration is getting transferred to the other areas. And this kind of a vibration dampers, these are taken care that your vibrations are not going very high. This is a let's say kind of a layout from inside cell. Again, a battery storage is here. Environmental chamber here. Then you are having a conditioning unit. It may look like. What is more important here is the cable routing, earthing, and other things are there. And also this test cell will be a kind of a, you can have a different climatic conditions, temperature control. Mainly we are using a same temperature always, because to see the performance. If you are doing a different performance and your environmental conditions are not same, maybe you cannot correlate the data. Also if any accident happens, any leakage, any problem with any of the equipment or UUT or systems, generally the exhaust blowers are installed there, so they will take care that everything, fire or smoke or something goes out. So this is a picture of a test cell area. Just to see that, let's say left side this is a dynamometer and right side there will be a motor. But how it looks like, because it is a high speed testing, so what is happening generally, the dynamometer is connected to a kind of a gearbox here, but this is not the vehicle gearbox, this is the general gearbox. So in different combinations, sometimes it can increase the speed or decrease the speed, and different kind of a temperature sensors, vibration sensors are connected here. So if anything happen, and these vibration sensors, for example, are taking input from the system, if something wrong with the some loose or something wrong with this vibration, sensors can give you a kind of input to the automation that something wrong there. So this is the inside picture of a dynamometer and testing area. The automation system for e-motor and inverter more or less remains same, but again it has a different combinations, like when it is in off condition, no power can go, you can bring in standby condition, everything is okay and conditioning is happening. When you are running, so you know how much is the voltage current flowing with this, you can have a different you are monitoring your combinations there. And then you can have a different possibilities. to help the operators to pre-program. You can make a pre-program, you can define the different cycles, and when these cycles are running there, so automatically data capturing is happening. In avial term, this is called a Puma system, but different combinations are possible. But the purpose of automation is pre-programming, collecting all the data, having all the errors indicating, controlling all the devices centralized, so there is no problem. Some of the important uses functional tests can be some kind of offline where test facility is not required. Let's say winding resistance measurement, hogging test, open circuit, closed circuit, short circuit. All these tests are also programmed, but running of motor is not required and different combinations are possible. So let's say back EMF test is one example which can be done with the different setups, with the different combinations possible. Then kind of a functional test for the back EMF, and then different combinations, different test cycles are done. Test cycles are mainly just to understand two types. One is the development, and second is the certification. Because our local agency, which is mainly ARI in India, they are having some kind of a legislation. So when you are checking a battery or when you are checking a motor or inverter, there are some guidelines. So if you are running a certification test, then you have to refer the ARI guidelines and you have to run the test. But if you are developing, so you need not to refer the guidelines. You may have your own guidelines, or you may have the guidelines from ARI, but you can have your own limits during testing. So all these possibilities are there. Then the peak performance test, or how my motor will be working when it is working on a full charge battery, how my motor will be working when it is, let's say, 80% charge battery. Different combinations, different possibilities are available there. E-motor emulator, I have told you, but say e-motor emulator is like, let's say you are developing a inverter, for example, and you don't have a motor. So this devices will work as a e-motor emulator, and how this will happen, and this will come in the coming up slides. How a e-motor emulator can support me not having a physical motor, but this device will work as a can support me to develop a inverter. So what are the developments inverter when it comes to the battery, e-motor and inverter? As per my understanding and feedback from industry, inverter is the let's say highest intelligence device. This controls battery, this controls your e-motor, and this controls your overall efficiency of the vehicle. So if your inverter is really optimized, so more intelligent inverter will be having the vehicle, then this will be the real benefit for the passenger car and for the final product. So what is here because during actual testing, what is happening, what is the discharging method, what is the charging method, different kind of a controls, in which mode I should give the power, how much power, how should I limit my current with this components, because you want to use the most reliable components. You have to see the cost wise also what is happening, and if you are using different interface connectors, these have to be there. If the battery or something happens to the inverter, general inverter scares, and the operational environmental conditions also. Let's say different temperature conditions, or let's say when you start in the beginning, when you are running a different cycles, durability, all these are also apply for the inverter testing. So as we have discussed, but once again to tell you that, let's say you have a motor, you need AC, you have a DC available, you have a battery, and the combination between, because changing from DC to AC and AC to DC, my inverter involved here. Just to know the very basic, maybe who are not directly from electrical side, is generally what happens. Let's say DC a voltage available with you, and with the help of, let's say, three sets of IGBTs. So what is happening? The IGBTs are doing a switching in a like a this is working for the first phase, this is for the second phase and third phase. So our switching is done in such a way that my DC gets converted to AC, and my frequency decides the speed of the motor. But when I'm working as a generator, so again AC power is generated here, and once again IGBT is working in a reverse way, and then this is converting to the AC. A capture here is used mainly in this inverter circuit. Different. This is also kind of an optimization. What type of capacitor you should use? If it is too big, it is not good. If it is too short, it is not. So, what should be the optimized base of this capacitor? What this capacitor done generally, especially when you are working in generator mode, suddenly you get power back and you get some DC voltage, but this cannot be consumed by battery immediately because charging circuit will take some time. So this capacitor is helping to retain this charge for a shorter time, and then this is giving to the battery on the other way. So this capacitor optimization is a one this thing. Let's see some more important parameters when it comes to the inverter testing. If you take example of a vehicle, of course, e-motor, transmission, inverter, battery. And when it comes to the testing, how I am doing it, let's say inverter remains inverter. Now e-motor, real e-motor is not required for me. E-motor emulator I can work. How e-motor and then battery. So with this combination, how I test here, most common motors which are available in the market. So all the parameters available there, and again the battery available there. So I can have a combination, let's say X battery and Y motor, how my inverter should work or how my inverter will behave. So different combinations you can select from here through the software, and you can develop your inverters. So emulator e-motor helps you to make your testing and your development very fast. So you are not dependent on a particular motor and a particular battery only. And even if something happens wrong, because this is much more safe area. Let's say even during testing, during development, you do some minor mistakes. It will not destroy your motor or battery, because they will take care. As soon as the limit is crossed, you get a combination, you get a warning here. So less chance of any error. And then of course you are more flexible, very fast, and you can check different functionalities, and in the safe environment you can do this combination. When it comes to the test beds, let's say you have an inverter and you have an inverter table where inverter is installed. This is e-motor emulator. So this has a different combination. So when you select a particular motor, this will consume the energy in such a way, like these are kind of an inductive load. So this will be working exactly like a, there is no rotating part, but this will be giving you, let's say, a kind of a combination as a e-motor. What else is required? You need, let's say, e-storage, which will be work as a battery. You need a kind of an automation system, and this e-storage is giving a voltage to this. So inverter is checked here, e-motor is available here. Again, my storage battery emulator and battery e-motor inverter is done. If you see the internal layout of inverter will be again, this is an inverter table, battery emulator, we know now. Your power analyzer, so this will give you all the voltage signals and sensor. Coolant conditioning unit, you know, because inverter or e-motor, they need some kind of a cooling temperature control. Automation is controlling everything. E-motor emulator, we know now. Fault insertion, because what is happening, some kind of a short circuit, some kind of a test can be held. So let's say if we want to check how the inverter will behave when my motor has a short circuit. So all these combinations are possible with this. So there are different contactors and different switches which will work as per my requirement. and they will simulate kind of a short circuit of other test areas here. So this is an overview for an example of a, let's say, inverter test bed. A little bit so power supply goes to battery generator, goes to inverter regulator. Yes, primary chamber. This see reduce voltage. So here and so this device have to see how inverter is behaving and used for all power like current is analyzed here and they are going to the system. Safeties, if a door lock is involved there, like one example I'll give, let's say there is some problem, there is some error and you want to open, for example, this e-motor emulator, you cannot open, you have to wait, let's say for around 10 to 15 minutes, and this is automatically done. Even if you try to open this, there is a timer working, you cannot open this, you have to wait. So all these safeties are generally given here, and different kind of tools available which can support you for your testing. I talk a little bit, but this slide is also giving you why inverter testing is required, because let's say you have an inverter 1, inverter 2, inverter 3, and you have a, let's say, E motor A, B, C, and you want to achieve a kind of a final outcome, a final development. You have to make different combinations. A plus B combination, 1 and B, C, different combinations. So what is happening if you are having a e-motor emulator and you are having a battery emulator, the inverter testing can be done. You are not dependent actually on the actual motor available. And this emulator is giving you the range of all motors available currently most popular in the market. This is again maybe the people who are not directly from the electrical side, just understanding. So let's say high voltage battery available here. You have a DC here. This is DC link capacitor. This is power electronics, which is changing DC to three phase or three phase to DC. And this is the control circuit. So e-motor we are getting back. So even the let's say rotor position, if it is a because like we have a if you know the engine, basically we are doing a different tappet setting and different combinations are happening. So for the motor also, because this has to be optimized on three phase. So even the rotor position and the zero position, 0 degree, 360 degree, this degree, all this coming here. So this is part of inverter. So this control circuit takes care for, ultimately it is responsible for power electronics, but this is taking input from e-motor and all other combinations. As we discussed, the power flow, when it works as a motor, power flow go from battery to e-motor. But when it works as a generator, this comes back and battery gets charged. This is just one example of how the inverter, one of the inverter may look like. So it has a different, this is like a connector for a high voltage, which is connected to the battery. Then it's like one example of CAN network, which will be connected to your vehicle. This is a driver's board having most of the control here. Then you have a DC link capacitor, you have a three-phase connections, which will be going to the motor, and then you have a coolant basically, because your coolant will be flowing inside doing the cooling of this is just one example, and this is the another example how it happens, different combinations. You have a battery, high voltage, you have an inverter, you have a motor, and you know now the DC, AC, and all these things what is happening. This is like one combination which is mainly used. So how it is happening here? Let's say this is the real battery, motor, and inverter. And when you do in the testing environment, you replace left side of e-motor storage emulator and the battery basically. So this is the testing environment, and finally it will be the actual environment. Then, and this is giving you one example, because let's say you are checking the efficiency, for example. So how it is done, how much, let's say, power from battery is reaching to inverter, I'm measuring here. How much, and DC measurement is done here. How the AC voltage is reaching the motor, I measure it here. When I'm loading the motor, I'm using the torque and speed, so I get the mechanical power here. And so between this, I know what is my inverter efficiency. Between this, I know what is my e-motor efficiency. And finally, my e-drive efficiency, or my, let's say, vehicle efficiency. So this is like one example when you are doing a different efficiency test and different kind of development. These are some software tools. I tell, this is like real combination. You can get different combinations. So for the overall development support software, there are four important things. One is the Cameo. This is like a calibration tools, because when you are optimizing your motor or inverter, this helps you, this supports you, this will guide you how it is to be done. Then you have a smart mobile situation. When you are running this application, when you are doing the testing vehicles, so this software is a kind of guidance to the user that how it can be done. And Concerto is a post processing. When you have done the testing, how to generate your final report. So all the data will become in a predefined templates. This is done the Concerto. And the Creta is again a kind of a life cycle management, different combinations. So these tools, let's say this example by AVL, but these tools are developed based on the data available, based on past testing done. And these are the tools who are supporting our user to do the testings. My last slide, just giving you a overall testing combinations. Let's say when you have a IC vehicles, so what you need a emission test on engine chassis dyno. So emission test is done here. And now I think you all know the real driving emissions basically. So RDE has to be done when it is happening. So chassis dyno and on-road testing is required. This is an example of a passenger car. When it is a plug-in hybrid, so the soaking, so your charging and the soak area, your charging has to be done. Then you have to test on a vehicle chassis dyno, and RDE has to be done. When it comes to the battery vehicle current situation, your charging is required, chassis dyno required, but real driving emissions in current scenario is not required, because EV plug-in vehicle does not have any emissions. And even if it's a fuel cell, then even the charging is not required here, because fuel cells works on hydrogen fuel. So only chassis dyno. So IC vehicles, plug-in, battery, and the hybrid. So in combination of battery vehicle, let's say these two testing areas will be required. So I try to maintain the time. I hope, but I'm available. No problem. So we can go for a quickly if there are some questions around. I hope my technology wise, my voice, my presentation went well. I hope so. Just a feedback if it was okay, and if there are some questions, I'm available to answer.
Thank you, sir. Thank you, sir, for your excellent presentation. And thank you for enlightening us through all the testing facilities in the in the inverter as well as in the EV batteries. Sir, there is a question in the chat box.
Yeah.
What are the different cooling techniques for EVs and HEVs batteries? Are these techniques provide sufficient cooling to avoid possible damage?
Yeah, three combinations possible as present. There are three combination possible. Combination one is a cooling fan, because when temperature goes beyond a limit, fan starts working automatically. This is one method. Second comes the oil cooling. So like a special a dilute oil is flowing, and this is taking care of the cooling arrangements. Let's say oil is flowing. Third comes the coolant. We can call it water, but it's not water. Basically, it is a combination of glycol and this. So then it is flowing and it is taking care. If it is sufficient or not, I think this has to be decided by the manufacturer. But every battery, they will be specifying a range that my battery will operate in the best way from this temperature to this temperature. And so how much, what is their cooling jackets, and how much is their flow, they are defining. Generally, they design in such a way that this is sufficient. So I will say, if a battery is tested properly and it is certified by ARI, for example, then yes, it will be fully capable of taking care for the cooling. So air, water, oil, these are three combinations.
So there is one more question from Mr. P. Tirumurthy. First of all, he thank you for your presentation, and he asked a question: how to realize the drive cycle variation in the test setup?
Yes. So it's like what is happening. I'll tell you, because in 1.5 hours I cannot discuss many things in automation, but I'll give you an example. We call a e-library. E-library is a guidelines in the software which will tell you how to do it. And e-libraries are what legislation in India or global any country, what legislation wants, these cycles are defined in such a way that they will take care. So when you are running a cycle, or when you are selecting a UUT, unit under test, that I have to test this, you have two options. You can select from the legislative point of view, which where you will be guided by all methods like warm up test, how to load this, how to go to the full throttle, how to go to the maximum speed. Even if when the testing is done, for how long you should be away, you should not touch the e motor or battery or something. So in short, these guidelines are available. Generally, how the people are doing, they take this and you can edit the guidelines. So you take the guidelines which is most suitable to you, whatever you want, and then you modify this to make it best suitable for you. And this is taking care. This is something like, let's say, if you have to travel from your home to airport, earlier time you have to ask, you have to go with many people, and still you may try. But now if you open the Google, you see the Google map, then you get the guidelines. It's not necessary you follow this, but at least you get the better one. So automation is in most of the cases automation very well for the drives and combinations and safeties and sequence.
Any more questions? I think it's done from the participant sides. So thank you, sir. Thank you for your valuable time. It was a very informative session, and thank you for finding out time from your busy schedule to sit through this lecture, sir. So on
Well,
behalf
thank
of
you so
NITC,
much. Yeah, thank you so much, because I'm trainer and I'm working with AVL. I always enjoy sharing knowledge and giving whatever I know with others. And especially when it comes to the colleges, to be very frank, sir, when it comes to the college or the people who are involved from the education, either students or professors, I feel pride, or I feel very happy, because I'm helping them somehow, whatever I have. So thank you so much, and thanks everyone who was listening, or maybe see this presentation or whatever is this. So thanks everybody who listened to me and who organized this. Thank you.
thank you, sir. But thank you, dear participants. We will have the day 3 of our FDP from tomorrow morning at 9:30 a.m. Professor Navneet Arora will deliver his lecture in the morning session, followed by the lecture of Dr. Neeraj Gupta on recent EV technologies in the forenoon session. In afternoon session, Dr. Dinesh Balasubramaniam from deliver his lecture on introduction to hybrid vehicles. So thank you, dear participant. I'm calling off the meeting. Thank you. Thanks a lot.
Thank you.